Hello everyone, I'm Mrs. Suggs and I welcome you to IBSL Chemistry. I'm going to be recording video lesson number 1 on sig figs. I'll share my screen and go over the first 4 pages of the class packet. So please have the class packet out. So, what we're going to accomplish today is looking at the meaning of numbers. What is it about science that uses numbers differently? We'll review sig figs, and then we'll start a lab, or at least when you're in the laboratory, you'll be starting this lab on measurements with this instruments. So I'll begin with a deep philosophical question. Here we go. How many oranges are here? How many ounces are in a paper, or excuse me, how many ounces are in a pound? And how long is this paper clip? These are 3 different types of numbers that you need to recognize. So the answer to the first one, you counted 5. That is what I would call a perfect number because it's counted. There's no discrepancy in how many oranges are there. 5 is the number that's counted and it has no uncertainty, or I would say infinite significance. The second number, how many ounces are in a pound? That's a defined number. And because of it, it has a perfect number. It is a perfect number. There are infinite significant figures in this number 16 because it's defined. But the last number, 5.3 centimeters, is a measurement using this measurement device. Whenever we have a number that is a measurement, we have a limited amount of significance. It would be comical to call this paperclip 2.51376 centimeters. It would be a lie. We have to limit the number of sig figs we write down for this measurement because of our measuring device. So you can see if I use 2 different measuring devices, I should get 2 different numbers expressed to different degrees of significance. On the first measuring device, I know the number 2 is correct at the beginning of this measurement. But the next number, I'm going to have to guess between 2 and 3 centimeters. So the 2 is a certain digit, and the second number is a guessed number. We call that the uncertain digit. I can disagree with you on the uncertain digit, but we can never disagree on the certain digit. All these measurements have 2 sig figs because of this measuring device. But the better, usually more expensive measuring device gives you more sig figs. With this ruler, everybody is certain that the measurement is 2.3, but then what number do you guess? You always have to guess one number, and that guessed number out of the 4 to 5 is the uncertain digit. So both of these have 3 sig figs, but we can disagree on the uncertain digit. So on the cover of your class packet, you have a concept map, and it just keeps you grounded as to what we're doing in each lesson. In today's lesson, we're going to be looking at sig figs, calculations, and equipment. So, on page 3 in your class packet, I'd like you to take the time to read all of these because it forms an argument in why do we use sig figs. Take the time and read them to yourself. Here's another image found on page 3. As I pointed out in our introduction, there are these 3 kinds of numbers. Exact numbers that you count. Nobody's going to disagree with an exact number that you count. Defined numbers have infinite significance because everyone will agree how many inches are in a foot, or how many ounces are in a pound, or how many millimeters are in a centimeter. But it's measurements that are the type of numbers that we have to write down, thinking of sig figs. Whenever you have an instrument, it will set the uncertainty of the measurement that you're making. So measurements have inherent uncertainty. Read these boxes and make sure they make sense to you. We have 2 different rules for when we manipulate sig figs. There's one rule for when you add and subtract. This rule is explained on page 4 in your class packet. If you're adding numbers, all of which have limited number of sig figs, you can only express your answer when you add or subtract to the place value. I always think with the down arrow, the place value of the least significant number, which is 9.62. 9.62 centimeters goes to the hundredths place, so you can only write your answer to the hundredths place. Do not write down this bigger number. Only write down the number to the correct number of sig figs. There's a different rule for when you multiply and divide. My trick to remembering this is that I count the number of sig figs in each measurement. Here, I'm dividing a number with sig figs by a number with 3 sig figs. Do not write down this large number as portrayed on your calculator. Since 3 sig figs is the measurement with the least number of sig figs, only 3, you write your answer down to 3 sig figs. So you'll notice there's a different rule for adding and subtracting versus multiplying and dividing. So there are 3 skills you need to master in this lesson. First, whenever I give you a number, you have to recognize how many sig figs are in it. Second, when you do calculations, add and subtract, or multiply and divide, you need to write the answer to the correct number of sig figs. Third, when I give you a measuring device, you have to record those measurements with the correct number of sig figs. So here we go. This was from the summer packet. All of these are measurements with limited sig figs. You should take the time now to go through each one of these and think about the number of sig figs in the answer. I give you these measurements, you tell me how many sig figs are in them. For example, here, with a leading 0, it is not significant, so this number has 2 sig figs. This number, 3050, has 3 sig figs because the trailing 0 without a decimal point is not significant. If these rules are not comfortable for you, you need to do a little bit more work on strategy reviewing. I would like to point out to you, down here, I have 3 numbers written expressing different degrees of significance. In this first way of writing the number, the trailing zeros are not significant. So here we have 3 sig figs. But in this number, I have included a decimal point, and that decimal point is telling me all those numbers are significant, and so there's 5 sig figs in this number. Another way I can indicate a 0 as being significant is to put a bar over it. So this number has 4 sig figs. I show you these 3 representations because you might not have seen the last 2 in the summer packet. So when you add or subtract numbers, see this arrow? You go to, you can move it, you go to the place value of the least significant measurement. So I can only write my answer to the 10th place. When you multiply and divide, you have to look at the 2 numbers that you're using and only write the answer to the number of significance as the least significant measurement. Here I have 2 sig figs times a measurement of 1 sig fig. I can't write this number as the answer. Do not even record it on paper. Instead, record the answer to the correct number of sig figs. 1 sig fig. Here at the bottom, you have a 5 sig fig measurement divided by a measurement with only 3 sig figs. So you can write your answer only to 3 sig figs. Not this big detailed answer. The third rule you need to learn today in class is how to read sig figs correctly off of an instrument. When you're dealing with an analog instrument, there are going to be lines on the instrument. And the rule of thumb is you can only guess 1 digit in between the lines. That will be your uncertain digit. We can disagree on the uncertain digit, but we have to agree on all the other sig figs. Remember, the sig figs are all of the certain plus 1 uncertain number in a measurement. So if you look at this first graduated cylinder, everybody knows the volume of this liquid is more than 2 mils, less than 3 mils. But what are these little lines representing? 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. We know that the volume of liquid is more than 2.6, but not 2.7. We get to guess a number between those lines. I could divide it in half. I could divide it by tenths. I could divide it by fifths. You get to choose how to guess the uncertain digit. But we have to agree that this volume is 2.6 something. The same is true for these measurements using these instruments. I want you to try to write these measurements. I'll pause, and then I'll go on to the slide with the answers. So here, all of these answers agree that the number for the measurement is 2.6, and we're guessing 1 uncertain digit. We can disagree on the uncertain digit, but not in the certain digit. We all have to write 3 sig figs for the measurement of this volume. Here, we all agree that the temperature is in between 87 and 88. So we can guess that next digit. So all these temperatures are the 3 sig figs. This is the most difficult because I know this volume is 6.7, but I need, 6.6 mils, but I need 1 more guess digit. I'm going to call it a 0. This could be the most common mistake that students make. A note about scientific notation. When you write a number in scientific notation, you express that number in correct sig figs. If you're writing this answer to the 5 sig figs that should be in the answer, you would write the answer like this. If you wanted to express that number in only 1, 2, 3, or 4 sig figs, you would write it like that. Scientific notation will automatically put your measurement in the correct number of sig figs. So you're going to go into the lab and you're going to look at several kinds of instruments. An analog instrument has lines on it. Remember, the general rule is you get to divide the smallest interval. How you decide, either by tenths, by fifths, or by halves. But you must guess one of those digits to make the number of sig figs in the measurement. These are analog measuring devices. Here I have different lines than here. That means I get different measurements when I record them. I get more sig figs from this ruler because it has more lines. Here I have that graduated cylinder. You tell me what the measurement is in this graduated cylinder. Is this what you got? Did you say 30.50? Because you're guessing the 0. Nobody's going to guess the 0.5. Here I have 2 more instruments for you to measure the volume in. Be careful, this volume looks to be on the line. You must guess one digit. This volume measurement is in between the 40 and 50. Make sure you guess a digit between 40 and 50. We all agree it's more than 40 and less than 50. Think of your numbers and record them. Did you get these answers? Now, when you have a digital scale, you write down that number knowing that the last digit that's demonstrated on the instrument is the uncertain digit. We're going to assume that the last digit can be plus or minus, one up or one down, in the digit that is last. So here on this balance, we would say that there are 5 sig figs in this mass, with the 5 being the uncertain number. On this digital thermometer, we're going to say that there are 3 sig figs in this temperature, but the 8 is the uncertain digit. Even digital instruments have a limited number of sig figs, with the last digit being the best number the instrument can get, but the uncertain digit. So I have practice here for you on Schoology that you can do for additional comfort with this skill. If you go through and try to answer these measurements, the answers are posted on Schoology. So the summary of lesson number 1 is, can you identify 3 different types of numbers? Only this last type of number has sig figs. Why is that? Because exact numbers or counted numbers are perfect. They have infinite significance. Defined numbers are perfect. They have infinite significance. But measurements are the numbers that have sig figs. Do you recognize the sig figs in these numbers that I'm giving you? Number of sig figs here, 4. Number of sig figs here, 4. Number of sig figs here, 3. Can you add these numbers together and get the answer to correct sig figs? You would only write your answer to the hundredths place. You would write the answer as 0.68. That's it, grams. Here, when you're multiplying or dividing, you write the answer to the least number of sig figs that a measurement has. So if you have a number with 3 sig figs divided by a number with 2 sig figs, you would write the answer to 2 sig figs. The answer here would be 2.0 grams per centimeter cubed. Can you read a digital measuring device? The 0 would be the uncertain digit. Can you read this analog measuring device? The answer would be 32.0 milliliters. That's the summary of lesson 1. And I thank you for your time in doing this. Get help if you need it. Otherwise, I'll see you in class.